The small paragraph on top of this page pretty much summarizes what we said earlier in another video about having areas above the x-axis versus below the x-axis. So in fact, for this problem, the 525 would not be called the area. It would actually be called the net area, because some of the region that we were discussing is underneath the x-axis. Whereas for this problem, the whole region is above the x-axis. This is the reason why I call it the actual area. So this amount that we got over here is in fact the physical space underneath the curve. But over here on this problem, the number that we got was not the physical space underneath the curve. It was the sum of the negative parts with the positive parts. Now, in example number 6, we have an equation. And in this problem, the equation is called p prime of x, which is the derivative of p. That's what we call in mathematics the marginal profit. The derivative of profit is called the marginal profit. We've only used that word once before, but that's what it means. So in this case, it's talking about the airlines having marginal profit from selling X seats, and it's given by this formula. So this formula predicts basically how much in hundreds of dollars the company is going to profit from selling 1 extra seat or 2 extra seats or whatever. X represents the number of seats. So find the total profit when 60 seats are sold. So basically what they're saying is they want the profit P of X, which is the antiderivative of the P prime of X. So again, to remove the apostrophe, to remove the derivative, we do an antiderivative. Now they want 60 seats in total. So that means they want the antiderivative to end at 60. Where does it start? Well, if you're a company selling seats on an airplane, you can either sell 0 seats or 1 or 2 or all the way up to 60. So the minimum can be 0, the maximum has to be 60 because that's what they asked for. So again, we're integrating 0 to 60, and the p prime of x is square root of x minus 6 dx. And to integrate, we're going to convert the square root of x to be x with an exponent, because we need to know the antiderivative by adding 1 to the power and dividing by the same thing. And so the antiderivative for x to the 1/2 becomes x to the 1/2 plus 1, which is 3/2, divided all by 3/2. The antiderivative for 6 is going to become 6x. And we swap the 0, 60 to the right. Okay, so the antiderivative for x to the 1/2 became x to the 3/2 and everything else. The antiderivative for 6 became the 6x. Okay, by the way, x to the 3/2 divided by 3/2, that's the same thing as 2/3 x to the 3/2, and then minus the 6x. So all I did there was remember the fact that if I'm dividing by a fraction, that's the same thing as multiplying by the reciprocal of the fraction, by the upside down, by the inverse. And at this point, we plug in the upper bound, and we plug in the lower bound, and the calculator will take care of the rest. So 60 is the upper bound, that's why I'm plugging it first, and 0 is the lower bound, so that's why I'm going to plug it in next. And make sure that you put the brackets everywhere, because your minus has to go to all the terms that were in the second bracket. If you forget the brackets, you're going to get that second term wrong, and it's never going to turn out to be right. You're always going to get the wrong solution. Now, this is a real-life example, so I'm fine with decimals. So I'm going to go ahead and plug it all into the calculator, hit enter, and see what happens. If you're interested in the exact solution, it's 80 square root of 15 minus 360. Or the decimal version of this, it's negative 50.16. And I wrote the solution and what it means down here for you, so you don't have to worry about writing it down. Selling 60 seats is a bad idea for this company. They're going to end up losing $5,016. So you probably want to sell more seats. That's why they stack airplanes with hundreds of seats, because if you sell a very small amount, gasoline, fees, and whatever is going to, cost you a lot of money, and you're not going to profit anything. So in this case, on this flight, the airplane is losing money. So you don't want 60, you want more seats to be sold. Now, if you really want to see the picture of what we just did, let me go ahead and graph it for you so you can see. So here's the graph. And as you can see, the graph is below the x-axis for this function. So this blue thing that we're drawing extends forever this way. And that's the graph of y equal to square root of x minus 6. And we're starting at 0 and we're ending at 60. That's why I'm only drawing that portion of it. And the area that we're looking for is pretty much, or the problem that we did looks for the area down here and the area up here, basically. And it combines them together. So now you could see that the orange area is way smaller than the yellow area. As a matter of fact, it takes from 0 all the way to 36 to even cross the x-axis. And so there's a huge chunk of area below the x-axis. That's pretty much all considered losses. And the area from 36 to 60 is above the x-axis, and that's considered to be profits. And as you can see, because the yellow area is bigger than the orange area, the answer is going to be at the end negative. And that's what we found when we actually did the problem. We discovered that the solution was a negative 50. So, again, losses. But if I extend the line a little bit more, then I'm going to be able to gather more orange space and I'm going to start making some profits. But if you stop at 60, then you're going to lose money.